A computer consists of four major parts: the input, output, CPU, central processing unit, and memory. Input consists of anything you will add into the computer: microphone, keyboard, mouse, scanner, and output is how the computer gives back to you: think screen, speakers, etc. Many programs functioning together to do a task make a software. There are three categories of software: system software, for example Windows operating system; application software, for example Photoshop; utility software, for example antivirus. Software is more than just a program code. A program is an executable code, which serves some computational purpose. Software is considered to be a collection of executable programming code, associated libraries and documentations. Software, when made for a specific requirement, is called software product. Engineering, on the other hand, is all about developing products, using well-defined, scientific principles and methods. The process of developing a software product using software engineering principles and methods is referred to as software evolution. This includes the initial development of software and its maintenance and updates, till desired software product is developed, which satisfies the expected requirements. One. Communication. Customer submits his request to the service providing organization in writing. 2. Requirement gathering. The team holds discussions with various stakeholders from problem domain and tries to bring out as much information as possible on the requirements. The requirements are contemplated and segregated into user requirements, system requirements and functional requirements. 3. Feasibility study. After requirement gathering, the team comes up with a rough plan of software process. At this step the team analyzes if a software can be made to fulfill all requirements of the user and if there is any possibility of software being no more useful. It is found out if the project is financially, practically and technologically feasible for the organization to take up. 4. System analysis. At this step the developers decide a roadmap of their plan and try to bring up the best software model suitable for the project. System analysis includes understanding of software product limitations, learning system-related problems or changes to be done in existing systems beforehand, identifying and addressing the impact of project on organization and personnel, etc. The project team analyzes the scope of the project and plans the schedule and resources accordingly. 5. Software design. Next step is to bring down whole knowledge of requirements and analysis on the desk and design the software product. The inputs from users and information gathered in requirement gathering phase are the inputs of this step. The output of this step comes in the form of two designs: logical design and physical design. Engineers produce metadata and data dictionaries, logical diagrams, data flow diagrams, and in some cases pseudocodes. 6. Coding. This step is also known as programming phase. The implementation of software design starts in terms of writing program code in the suitable programming language and developing error-free executable programs efficiently. 7. Testing. An estimate says that 50% of whole software development process should be tested. Errors may ruin the software from critical level to its own removal. Software testing is done while coding by the developers and thorough testing is conducted by testing experts at various levels of code such as module testing, program testing, product testing, in-house testing and testing the product at user's end. Early discovery of errors and their remedy is the key to reliable software. 8. Integration. Software may need to be integrated with the libraries, databases and other programs. This stage of SDLC is involved in the integration of software with outer world entities. 9. Implementation. This means installing the software on user machines. At times, software needs post-installation configurations at user end. Software is tested for portability and adaptability and integration-related issues are solved during implementation. 10. Operation and maintenance. This phase confirms the software operation in terms of more efficiency and less errors. If required, the users are trained on, or aided with the documentation on how to operate the software and how to keep the software operational. The software is maintained timely by updating the code according to the changes taking place in user and environment or technology. This phase may face challenges from hidden bugs and real-world unidentified problems. 11. Disposition. As time elapses, the software may decline on the performance front. It may go completely obsolete or may need intense upgradation. Hence a pressing need to eliminate a major portion of the system arises. This phase includes archiving data and required software components, closing down the system, planning disposition activity and terminating system at appropriate end of system time. Waterfall model is the simplest model of software development paradigm. It says all the phases of SDLC will function one after another in linear manner. That is, when the first phase is finished then only the second phase will start and so on. Iterative model. This model leads the software development process in iterations. It projects the process of development in cyclic manner, repeating every step after every cycle of SDLC process. The software is first developed on very small scale and all the steps are followed which are taken into consideration. Then, on every next iteration, more features and modules are designed, coded, tested and added to the software. Every cycle produces a software, which is complete in itself and has more features and capabilities than that of the previous one. Spiral model is a combination of both the iterative model and one of the SDLC models. It can be seen as if you choose one SDLC model and combine it with the cyclic process iterative model. This model considers risk, which often goes unnoticed by most other models. The model starts with determining the objectives and constraints of the software at the start of one iteration. The next phase is of prototyping the software. This includes risk analysis. Then one standard SDLC model is used to build the software. In the fourth phase of the plan of the next iteration is prepared. V model. The major drawback of waterfall model is we move to the next stage only when the previous one is finished and there was no chance to go back if something is found wrong in later stages. V model provides means of testing of software at each stage in reverse manner. At every stage, test plans and test cases are created to verify and validate the product according to the requirement of that stage. For example, in requirement gathering stage the test team prepares all the test cases in correspondence to the requirements. Later, when the product is developed and is ready for testing, test cases of this stage verify the software against its validity towards requirements at this stage.
Thank you. Have a nice time always.